our parent graph is going to be the graph k of x equals 2 to the x power. And then we're going to take that and move it to the right. So 2 to the x power, we graphed it up here. First of all, we're going to draw the asymptote, which is that line that it approaches but never touches. And it's going to have the point 0, 1 on it. And then as we move to the right, we're going to double. So 2 times 1 is 2. And then 4, and then 8. And if you don't remember those points, you can just grab those off of your graphing calculator. And then as we go to the left, we're going to cut those in half. So 1/2, 1/4. And we're going to connect those. So this is our parent graph. This is our original. But this problem is asking for a graph that has been moved to the right 1 unit. So all we have to do is take all these points and move them to the right 1 unit. So all these points, we can connect them. And we're going to end up with this. So this graph in black is our correct answer. So this is what we want. So the domain is going to be all real numbers, and the range is going to be from 0 to infinity. All right. Let's try number 5. Number 5 is a little bit tougher because we have 2 things going on. The first thing there is a negative x, which means that we are going to reflect over y. And then the second thing is a +3, which means we're going to move up 3. So I'm going to do the same thing I did the first time. I'm going to draw that parent graph in orange just so you can see where it comes from. So k of x, I know it says m of x, but we use k of x up there, is going to be 2 to the x power. So again, if you don't remember those points, you can grab them off your graphing calculator. Your asymptote's going to go through the origin, and then we're going to have a point at 0, 1, and because our base is 2, we're going to double that. So 2, and then 4, and then 8, and then we're going to cut it in half going this way. And if you connect all of these, that's our parent graph. So there's 2 things we're going to want to do here. We're going to reflect this over the y-axis. So all these points, we're going to take them and we're going to go bloop, and we're going to flip them over the y-axis. But we're also going to take those points and move them up 3 units. So let's start with this point right here. We're going to reflect it, so it's going to end up right here. And then we're going to move it up 1, 2, 3 units. So its new spot's going to be up here. Then we're going to take this guy right here. We're going to reflect it, and then we're going to move it up 1, 2, 3 units. So its new spot is going to be right here. Then this point right here, reflect, and then up 1, 2, 3. And then this point right here, if we reflect it, it's still on the y-axis, but we're still going to move it up 1, 2, 3. But the most important thing is that asymptote, which was normally going through the origin, is also going to move up 1, 2, 3. So when we connect our points, we will know what line to approach but never touch. So our graph is going to look like this. Let me do a nicer job there. There we go. So the domain of this guy is still going to be all real numbers, but the range is going to change a little bit. The lowest that this guy goes now is +3, and the highest it goes is infinity. So pause the video and take a chance to try numbers 4 and 6 on your own, and then we are going to take a look at something else, but we're almost halfway done.